welcome back, still on Unit 1, and this PowerPoint is going to be about algorithm design. What is algorithm design? Describing a step-by-step strategy to solve a problem. So it's the same as saying algorithms, they just label it algorithm design because you need to know how to design an algorithm. Again, the two main types of algorithms that we'll be using in this one are pseudocode and flowcharts. Pseudocode is a textual description of the logic that needs to be followed, whereas flowcharts is a pictorial, so a picture describing the logic that needs to be followed. Let's look at pseudocode first. So pseudocode is like a rough draft or blueprint for a computer program. No one size fits all. You can make it your own mostly. So pseudocode, there are some keywords that you have to kind of stick to, but again, once the logic is explained in a way that anyone can understand it or a programmer can understand it, you're good to go. Pseudocode is textual. Again, it is text that describes the logic of the system that you want to develop. Flowcharts use shapes or images. So here's a very super simple pseudocode example. So we start the program, we input the length of the rectangle, then we input the width of the rectangle, we calculate the area by doing length times width, which is done here, and we display the area. So this might just be a print statement in Python, and then that's it, you're done. So for the pseudocode that we just looked at, I actually went ahead and wrote a Python program just to do this quickly. It's pretty straightforward, I think. So again, we're going from pseudocode to code, and we're using Python 3. So we get the length from the user, so float input. This is something that we will be going over later on, but don't worry about it now. The length here, this is the variable name called length, and what this allows us to do is to store any value that we want in this. This thing here that says equal tells the program that anything that's typed in by the user, this is going to be where it's saved, the saving length. This thing that says float, that just tells it that this is going to have decimal points or could have decimal points. The thing that says input, that tells the computer or the program that the person needs to type something in after this stuff is shown. So hopefully that explains it a bit. I will be going over this in more detail, but simply going from pseudocode to code, we get the length, which is what this first line does. The second line gets the width. The fourth line here calculates it, so we do length times width, and the sixth line here simply prints the value that we get. Here are some keywords I grabbed from the BBC Bite Size website. I will put the link in the description as well, but these are the typical key phrases or keywords that we can use to almost describe any system, I would say. And for this level, this should be more than enough. So we have input, output, while, for, repeat, until, if, then, and else. So input obviously tells you, take out the obviously. Input indicates a user will be inputting something. So if I go back to my program here, this is why the word input is used here. And one of the reasons that people who are learning to program typically tend to use Python is that it's very close to English readable language. So you can read this and it will kind of just make sense. So if I go back to this, output indicates that the output will appear on screen. So if I go back down here, this print thing here is going to put a value on screen. And that's what it means by output. A while loop is an iteration that has a condition at the beginning. We haven't looked at while loops yet. We will look at it at some point, but let's just say while the person's age is not, I think 21, you are not allowed to drink. That's one example. A for loop is going to be a counting loop or iteration. So we can do it X amount of times. So let's just say, for example, I have a list of 100 names. So I can say again in Python, for item or for name in my list, print the name. We will be looking at this later on, so don't worry too much. Repeat until, a loop iteration that has a condition at the end. And then the if, then, and else, a decision selection in which a choice, if, then, and else, a decision or selection in which a choice is made. Again, we will go over this, so do not worry. Here are some extra words that you might be able to use in your pseudocode as well. Get, process, and do. This is a pseudocode example again from the BBC website. So here, let's quickly read and try to understand what we have to do. So a program is developed to create usernames for a class of 20 pupils. The program will ask a teacher to enter the first name, surname, and age of each pupil. The age entered must be between 5 and 18. The program should output a list of usernames for the teacher. So if you look at the example that they gave, so the main step, initialize username. So get username, set username, that's the name of the thing that we're trying to do. So we start a fixed loop for 20 pupils. So we say, while student count is less than 20, again, we will go over this. Get first name and the surname from user, get valid age range from user, generate username, display username, the index. So that's going to be display username, index is username, end fixed loop, display username. The index is the location within the list of the 20. So for example, let's say we had a list of 20 down here, 1, 2, 3. Sorry about the writing, I'm using my mouse. And person 1 is called A. Let's keep it simple. Person 2 is called B, and person 3 is called C. The index would be the location. So in Python, the index always starts from 0. Then we have 1, and then the index 2. So even though it's the third item, the index is 2. So for example, this person's name might just be B, and their index is going to be number 2 in the list. So we will know from this that we have 18 more to do roughly. So this is how this works. This is a refinement of exactly the same pseudocode from before. So get first name and store first name, get first name and store in first name array, get surname and store in surname array, get age and store it in age array. While age is less than 5 or higher than 18, start conditional loop. That's simply saying age you entered is less than 5, so it will not be accepted. And if it's greater than 18, it will not be accepted. So it's saying display error message, invalid age, enter a number between 5 and 18 inclusive. This is just a thing that we can put on screen to say you entered something wrong, please try again. Get age and store in age array. End conditional loop. So this is essentially going to check, I think it's down to here. This is essentially going to check if the age that's been entered is correct. Next, we have concatenate first name, surname, and age and store in username array. Concatenate simply means to join. So they're using weird fancy names or words here. Concatenate means join. So for example, if I go back to my example before, we had person one was names was A, but let's just say that's the first name. Their second name might have been AB, for example. I'm doing really bad examples here, sorry. And their age might have been 10. So when we concatenate things, we simply join them up. So the full username for this person would be A, and then we concatenate, we add the AB, and then after that, we add the 10. That's it. That's all it means. Just join everything here together. That's it. Start fixed loop from 0 to index 1. If username equals stored username, add 1 to age. Start fixed loop from 0 to index -1. If username equals stored username, so if someone enters, so if the program creates a username and that username is already in the system, we can't use it obviously. So what it's going to do is add 1 to age. So that value that we had before, for example, this 10 here, we're going to change that to 11. And now when you concatenate it, it's going to be A, AB, and this is going to become 11. So it's going to be a different username. And we end, and then we end the fixed loop as well. I think I've tried to simplify it as much as I can here. So this is my interpretation. We start the program. We get input. The person enters their first name. We have a process that saves the first name to a variable or a list. This is not, again, exactly how you have to do it. This is just my interpretation of how I would quickly think about this in my head. And again, I'm thinking of using Python 3 here, but this will be usable for any language. Input, we have enter last name again. Process, save the last name to a variable or a list. Input, enter age. If age is less than 5 or age is more than 18, output, the age must be between 4 and 19 or 5 to 18. Else, process, save last name to a variable or list, output the username is, and whatever random username we decide to come up with, end, repeat. So this will just keep repeating every single time. I didn't add any counter or any checks in here to check if we get to 20 students because the person could just stop running the program. That was my logic behind it because I wanted to make it as simple as possible. So key things to know, think about the log or flow of the program, write this down or think about this in plain English. So you can write this in plain English first and then slowly start to add in the logic later on. Convert the notes or thought into pseudocode. That's what I just said. You must use some keywords. So even though, let me go all the way back to here, even though there's no fixed way to do this, having some keywords in there would make sense for the programmer. For example, if a programmer sees input and they're a Python 3 programmer, they know straight away they need to create a variable to grab some input and they'll save it to that value. Once they see output, they know they're going to be using a print statement and so on and so forth. These are all the keywords that can be used for pseudocode. So we have on page 31 and page 32 of the specification, which I will put in the description as well. You can go through this with your teachers by yourselves, but to be fair, you won't need to use every single one of these. You need to know the main ones, which I've shown already. But if you think you need to grab anything from here, please go ahead. Next, we're on to flowcharts. And for flowcharts, what is a flowchart? A visual diagram. So again, a pictorial representation. It uses shapes and arrows to show the step in a process. Shows the flow, the arrows connect the shapes and show the order in which things happen. Uses shapes for different things. For example, the oval starts and ends the process. The rectangle, actions or steps in the process. The diamond, decisions that need to be made. So it's normally a yes or a no. Benefits of flowcharts: making complex processes easy to understand visually, improving communication and collaboration. Because again, most computer people, most computer scientists, IT people, they've learned one or two of these techniques. So rather than sitting there and trying to describe something in plain English or in a paragraph, you can show them a flowchart and they can just start doing what they have to do straight away. Finding bottlenecks and inefficiencies, documenting processes clearly, increasing efficiency and reducing errors, more or less the same for all forms of algorithm design. So again, flowcharts, they use shapes. So we have the oval, which represents a start and end of a process. The rectangle represents a process, task, or action. The diamond represents a decision point. So yes, no, up, down. Parallelogram represents the input or output of data or information. The arrows connect the shapes and show the direction of the flow. Here again are some of the main shapes, and I grabbed this from the BBC Bite-Size website. I will put the link in the description as well. These are the shapes that you'll be using to create your flowcharts. Here's a flowchart example. So we start the program and we ask for. Some people typically tend to highlight exactly what this thing is doing. So for example, the same shape is here, but it's also down here with an output. So it says input, which is the best subject? Does answer equal computer science? No. Output says, okay, try again. You're definitely wrong. Computer science is by far the best subject, or engineering or IT, but it's one of those computer sciencey subjects. If it's a yes, the output is of course it is, and we stop. So this program, this flowchart here is kind of easy to follow. But again, these are the shapes that you have to use. The arrows need to be pointing in the right direction. You do not use bidirectional arrows. It must be a single arrowhead pointing outwards, telling you the next step to potentially go to. And here is my Python 3 representation of what we just looked at. So we say while true. Again, once we go through programming stuff, I'll explain all of this. But this essentially says, while this computer is working, while this computer has electricity, just do this thing forever and ever and ever and ever and ever. So this will just keep running forever and ever. So answer is the variable name. We tell it to equal to whatever the person types in here. And we tell it it's an input, and the person must answer this question. What is the best subject? If someone types in computer science or computing, then fine. But what I've done, I've said if answer is double equal sign, means it must be exactly equal to this. So there must be uppercase C, there must be uppercase S, it must be exactly like this. Print, of course it is, well done. And we break the program, and we break the loop here. Elif, or else if, whichever way you want to say, if the answer is not equal to computer science, error detected, please try again. Obviously a very silly example, but hopefully demonstrates how we go from this flowchart to this actual Python code. Because my PowerPoints are not just made for students, they're made for teachers as well. I've left some questions in here, so you might see me skip a few slides. It's not that I'm skipping it, I'm leaving those questions in there because I don't have time to go through everything, so that teachers can actually have questions in a lesson where they're presenting this for learners to actually go ahead and do. So this one is a pseudocode task, and this one is a flowchart task. That's one of the answers there, which I'm going to skip. And next time, the next video that I'm working on is programming paradigms.